Welcome to our comprehensive guide on force, work, power, and energy for ICSE Class 10. In this video, we'll break down these fundamental concepts in physics, making them easy to understand and remember. Let's start with force. Force is a push or pull that can change the state of motion or shape of an object. It's all around us, from opening a door to kicking a ball. Understanding force is the first step to mastering the rest of the chapter. As we move forward, keep in mind how force connects to work, power, and energy. Let's dive deeper into what force really means and how it affects our everyday life. Forces come in many forms. Some are contact forces like friction or tension, which require physical contact between objects. Others are non-contact forces such as gravity and magnetism, which act even when objects aren't touching. Think about how gravity pulls you towards the earth or how magnets attract metal objects. Recognizing the difference between these types of forces helps you understand the variety of interactions in the physical world. As we continue, notice how these forces play a role in the concepts of work and energy. Force is measured in Newton's N, named after Sir Isaac Newton. 1 Newton is the force required to accelerate a mass of 1 kilogram by 1 meter per second squared. You might see force measured using a spring balance in your school lab. Understanding how to measure force accurately is crucial for solving physics problems and conducting experiments. Next, we'll see how force is related to the concept of work. Work in physics has a specific meaning. It's done when a force moves an object in the direction of the force. For example, lifting a book off the table involves work because you apply an upward force and the book moves upward. If there's no movement, or if the movement is perpendicular to the force, no work is done in the physics sense. This distinction is important for solving problems and understanding energy transfer. SI unit of work is the Joule J. 1 joule is the work done when a force of 1 Newton moves an object 1 meter in the direction of the force. This unit helps standardize measurements and makes calculations easier. You'll often see work measured in joules in your textbooks and exams. Understanding units is key to solving numerical problems accurately. Work can be positive, negative, or zero. Positive work happens when the force and movement are in the same direction, like pushing a box forward. Negative work occurs when the force is opposite to the movement, such as friction slowing down a sliding object. Zero work is when there's no movement or the force is perpendicular to the direction of movement. These distinctions help you analyze different physical situations. Gravity is a classic example of a non-contact force doing work. When you lift an object, you work against gravity. When you drop it, gravity does positive work as the object falls. The amount of work done by gravity depends on the weight of the object and the height it moves. This concept is essential for understanding potential energy, which we'll discuss soon. Power is the rate at which work is done. It tells us how quickly energy is transferred or converted. For example, 2 people might do the same amount of work, but the one who finishes faster uses more power. Power is a crucial concept in understanding machines and energy efficiency. Let's see how it's measured and applied in real life. SI unit of power is the watt W. 1 watt equals 1 joule of work done per second. You might also encounter kilowatts kW in appliances and horsepower HP in vehicles. Understanding these units helps you compare the power output of different devices and machines. Next, we'll look at how power is calculated in various scenarios. Calculate power, divide the work done by the time taken. For example, if you lift a 10 kg box to a height of 2 meters in 5 seconds, you can find the work done and then the power used. This calculation is useful in everyday life, from understanding electricity bills to evaluating the performance of machines. Practice these calculations to strengthen your problem-solving skills. Energy is the ability to do work. It exists in many forms such as kinetic, potential, thermal, and chemical energy. Every action from running to lighting a bulb involves energy transfer. Understanding energy is key to understanding how the world works, from simple machines to complex biological systems. Let's explore the different forms of energy in detail. Kinetic energy is the energy of motion. Any moving object, whether it's a rolling ball or a speeding car, has kinetic energy. The faster an object moves or the heavier it is, the more kinetic energy it has. The formula for kinetic energy is Ke equals a half mv2, where m is mass and v is velocity. This concept helps explain everything from sports to vehicle safety. Potential energy is stored energy due to an object's position or state. For example, a stretched rubber band or a rock at the top of a hill has potential energy. When released, this energy can be converted into kinetic energy. The most common type is gravitational potential energy, which depends on an object's mass, height, and gravity. This concept is vital for understanding energy conservation. Mechanical energy is the sum of kinetic and potential energy in a system. It's the energy associated with the motion and position of objects. For example, a swinging pendulum has both kinetic and potential energy at different points in its swing. Understanding mechanical energy helps explain how machines and natural systems work efficiently. Law of conservation of energy states that energy cannot be created or destroyed, only transformed from one form to another. For example, when you ride a bicycle downhill, potential energy converts to kinetic energy. This fundamental law underpins all of physics and helps explain how energy moves through systems, from engines to ecosystems. Energy transformations are everywhere. When you eat food, chemical energy is transformed into kinetic energy as you move. In a light bulb, electrical energy becomes light and heat. Recognizing these transformations helps you understand how devices and living things function. It also highlights the importance of energy efficiency in technology and daily life. Work energy theorem states that the work done on an object is equal to the change in its kinetic energy. This means that when you apply a force to move an object, you're changing its energy. This theorem connects the concepts of work and energy, making it easier to solve physics problems involving motion and forces. Power isn't just a physics term, it's part of our daily lives. From the wattage of your light bulbs to the horsepower of your car, power measures how quickly work is done. Understanding power helps you make informed choices about energy use, efficiency, and cost. It's a practical concept that connects science to real-world decisions. Machines help us do work more efficiently by increasing the force or changing its direction. The power of a machine tells us how quickly it can perform work. For example, a crane lifting heavy loads or a blender mixing ingredients both rely on power to function effectively. Understanding how machines use power helps you appreciate engineering and technology. No machine is perfectly efficient. Some energy is always lost as heat, sound, or vibration. Efficiency is the ratio of useful work output to total energy input, usually expressed as a percentage. The higher the efficiency, the better the machine converts energy into useful work. This concept is crucial for designing and choosing machines in everyday life. Energy sources can be renewable like solar and wind or non-renewable like coal and oil. Renewable sources are sustainable and have less environmental impact, while non-renewable sources are limited and can cause pollution. Understanding these differences helps you make informed choices about energy use and conservation. Nature is full of examples of energy conservation. Plants convert sunlight into chemical energy through photosynthesis. Animals eat plants and use that energy for movement and growth. Even in natural disasters like earthquakes, energy is transformed from one form to another. Observing these processes helps you appreciate the interconnectedness of life and energy. Food we eat contains chemical energy, which our bodies convert into kinetic energy for movement and thermal energy to maintain body temperature. This transformation is a perfect example of the law of conservation of energy in action. Understanding how energy flows through food helps you make healthier choices and appreciate the science behind nutrition. Heat energy, or thermal energy, is the energy that comes from the movement of particles in matter. When you heat water, the particles move faster, increasing the temperature. Heat energy can be transferred by conduction, convection, or radiation. This concept is essential for understanding weather, cooking, and even the functioning of engines. Electrical energy is the energy carried by moving electrons. It powers our homes, schools, and devices. When you switch on a light, electrical energy is converted into light and heat. Understanding electrical energy is crucial for grasping how modern technology works and how to use it safely and efficiently. Chemical energy is stored in the bonds of molecules. When these bonds break during chemical reactions, energy is released. This is the energy you get from food, batteries, and fuels. Understanding chemical energy helps explain everything from digestion to the operation of cars and electronic devices. Sound energy is produced when objects vibrate, creating waves that travel through air, water, or solids. When you speak or play an instrument, you're creating sound energy. This form of energy is essential for communication and entertainment, and it helps us understand the physics of waves. Light energy, or radiant energy, is the energy carried by electromagnetic waves. It allows us to see and is essential for photosynthesis in plants. Light energy can be produced naturally like sunlight or artificially like bulbs and LEDs. Understanding light energy is key to studying optics and the behavior of waves. Nuclear energy is stored in the nucleus of atoms. It's released during nuclear reactions such as fission and fusion. This energy powers nuclear plants and the sun. While nuclear energy can produce large amounts of power, it also raises concerns about safety and waste. Understanding nuclear energy is important for discussions about future energy sources. Elastic potential energy is stored in objects that can be stretched or compressed, like springs and rubber bands. When you stretch a spring, you do work on it, storing energy that can be released when the spring returns to its original shape. This concept is important in mechanics and engineering. Gravitational potential energy depends on an object's mass, height, and gravity. The higher an object is lifted, the more potential energy it gains. When the object falls, this energy converts to kinetic energy. This principle explains everything from falling apples to roller coasters. Friction is a force that opposes motion. When you push a box across the floor, friction does negative work, converting some of your effort into heat. Understanding the work done by friction helps explain why machines need lubrication and why energy is lost in real-world systems. Simple machines like levers, pulleys, and inclined planes help us do work more easily. They allow us to apply less force over a greater distance. Understanding how simple machines work is essential for solving problems in mechanics and for appreciating the tools we use every day. Mechanical advantage is the factor by which a machine multiplies the force put into it. For example, a lever with a long arm can lift heavier loads with less effort. Calculating mechanical advantage helps you understand how machines make work easier and more efficient. In any machine, work input is the energy you put in, while work output is the useful work the machine does. Due to friction and other losses, output is always less than input. Understanding this difference is crucial for analyzing machine performance and improving efficiency. Every electrical appliance has a power rating, usually in watts or kilowatts. This rating tells you how much energy the device uses per second. Understanding power ratings helps you choose energy-efficient appliances and manage electricity consumption at home. Horsepower is another unit of power commonly used for engines and vehicles. 1 horsepower equals about 746 watts. Understanding different units of power helps you compare machines and vehicles from around the world, making you a more informed consumer and student. Conserving energy is important for saving money and protecting the environment. Simple actions like turning off lights, using energy-efficient appliances, and insulating your home can make a big difference. These habits not only reduce your bills but also help conserve resources for future generations. The way we use energy affects the environment. Burning fossil fuels releases greenhouse gases, leading to climate change. Switching to renewable energy sources and using energy wisely can reduce our environmental impact. Understanding this connection helps you make responsible choices for a sustainable future. Transportation relies on different forms of energy, from gasoline in cars to electricity in trains. Improving energy efficiency in transportation reduces fuel consumption and pollution. Innovations like electric vehicles and public transport systems are shaping the future of mobility. Homes use energy for lighting, heating, cooling, and appliances. Making smart choices like using LED bulbs and energy-efficient devices can lower your energy bills. Understanding how energy is used at home helps you become a more responsible consumer. Industries use large amounts of energy for manufacturing, processing, and transportation. Improving energy efficiency in industry can save resources and reduce pollution. Technologies like automation and renewable energy integration are making industries more sustainable. Technology relies on energy to function, from computers to smartphones. Advances in technology are making devices more energy efficient and environmentally friendly. Staying updated with these innovations helps you use technology wisely and sustainably. Let's quickly review what we've learned. Force is a push or pull. Work is done when force moves an object. Power is the rate of doing work, and energy is the ability to do work. We've explored different forms of energy, the law of conservation, and practical applications in daily life. Mastering these concepts will help you excel in your ICSE exams and understand the world better. Congratulations on completing this journey through force, work, power, and energy. These concepts form the foundation of physics and are essential for understanding more advanced topics. Keep practicing problems, observe these principles in your daily life, and stay curious. With a solid grasp of these basics, you're well prepared for success in your ICSE Class 10 exams and beyond.